Record. Okay. Now, I'm going to turn on live transcript. And let's see if this works. Use a third-party service, enable auto transcription. I don't want to assign anybody, just want to enable it. Enable. Okay. All right, so live transcript is set up and you can turn it on, I think, on your client side. I'm curious to see how that shows up in the recording. It may not. Because I know YouTube will put the transcript on after I upload it. Okay, today is the Logical Volume Manager. And Logical Volume Manager, did somebody ask a question or is that an open mic? Oh boy, I can hardly hear you. Is that a okay, that's an open mic. Okay, thank you. I will mute it. Okay, there we mute. There we go. All right. Okay, thank you. So I'm assuming you can hear me. Your silence is consent. So what we'll be doing is going through how to set it up and what we're doing. And I've been using Debian lately. I've just been tinkering with Debian because for the things I do not need bleeding edge kernels. And I have found that using bleeding edge kernels breaks a lot of user mode software. For example, my OBS, which is the open broadcast system, broke. My VMware broke. Other things are breaking. So it's because I'm using this cutting edge kernel. So what I need to do is actually roll it back and use an older kernel that's in the stable format. And I don't need all the bleeding edge stuff because I'm not using bleeding edge anything. Okay. It's okay to be there, but bleeding edge really makes more sense when you're actually on the bleeding edge. Okay. Using bleeding edge for, say, like you've got a brand new chipset from Intel and you're part of the Intel QA developer program and you want to make sure the kernel works on that chipset. Yes, that's a really good use case for bleeding edge. But business, by and large, you don't want bleeding edge because, bleeding edge is a tough way to, you spend a lot of time fixing bugs, okay? All right, so let's talk about the Logical Volume Manager and what it does. So I'm going to turn screen share off, click, and then go back to my wonderful clock and make sure my cord is long enough. Yeah, move the clock out of the way and zoom out and draw you some pictures that will look like a kindergartner. But what we'll have is an idea of how this works. Okay. So the Logical Volume Manager is a software abstraction layer that makes your disk drives interchangeable on your computer. Okay. Now let's assume I have a computer that has 1, 2, 3, 4 hard drives. Okay. And can you see that? Let me use black. Let me do that again. 1, 2. I thought about putting this up on PowerPoint, but I figured, nah, because the test out explains it with better diagrams. What I'm going to be showing you is just a quick overview explanation, and then the commands and how they work. So you can actually implement a logical volume manager. And this is actually really a lot of fun to do in your VM. And then I'll show you some trippy things you can do with your virtual manager. And I believe what I will be showing you will work in VirtualBox too. Okay. All right. So I have my 4 drives. And if I was in the world of Windows, they'd be C, D, E, and F. Well, if F dies, everything on F is gone. Well, in Unix, this is a part that's a little bit confusing to beginners, is everything in Unix is a mount point. And I'm using the term Unix specifically on purpose because this is across all of the Unixes that I've ever touched. You have a mount point that goes to a device, and this device is labeled dev, as in device, SDA. That's my first device. And then I have B, C, and D. Same thing. So if this is my SDA, here's SDB. Each one of these has a dev in front of it, okay? SDC and SDD, okay? So if I set up my machine, and let's say I'm going to use a mount point, and you'll see this in print. And if you use Kali Linux, it kind of does this automatically for you. What it does is there's this MNT directory, and then it mounts this drive underneath MNT. And for the sake of argument, I'm just going to call it SDB1. We'll come back to that in a second. So I have a folder, root, which is my entire subsystem. And in my root subsystem, I have a directory called MNT. And now I have a mount point, an actual place for disk, SDB1, right here. So there is no such concept as a C drive, D drive equivalent in Linux, Unix, is everything's a mount point. So when you mount your drives, so I mount another drive, I could actually do, let's not confuse everybody right out of the gate. We'll mount SDC and SD1. So each drive has its own mount point. Now, you should be through test out far enough to understand that much, I hope. If not, take notes, okay? Mount points, what are they? How do they work? Why are they important? It's mount points is one of the guiding philosophies, guiding principles, whatever you want to call it. It's one of the base foundation ideas of Linux Unix, okay? Okay, this mount point idea, okay? So SDC1, SD, so I have created a file folder structure, and I've got all these drives. And you're moving along, you're in production, you've got your whole database on SDC. Yay, it's working great, blah, 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 blah. Corruption, oh no, my drive died. Nothing wrong with the software. We have a hardware failure, and you're going, oh dear, now what? Well, like every good admin, you restore from your previous backup. And then you say, backup? What's a backup? You will do this a few times in your career, and you will become a backup paranoid idiot like me, backup everything way too many times. And then you have backups laying around, you don't even know what they're for, but you're you don't want to delete them because you know you might think you need them. Kind of collecting junk. You know, your garage gets fuller and fuller and fuller, okay? Logical volume manager When I used AIX from 97 to 2005, this was part of AIX. It was sweet. And the IBM kernel developers on AIX ported it to Linux. So it would, because IBM is not in the software business, they're in the hardware business, okay? They want to sell you boxes. That's somewhat changed over the years since they bought Red Hat. Now they want to get more into the service business, okay? The joke is Red Hat bought IBM, okay? Laugh or not, I kind of like it. It's kind of funny, okay? Well, here's kind of what happens with the logical volume manager. You still have your separate drives, but what you do with them is you create this abstraction layer to simplify your life, okay? And the beauty of it is it makes recovery so much easier. This concept of this abstraction layer, logical volume manager, software-defined networking, virtual machine, it's all just putting more stuff in software, another layer up from the hardware. In a shortcut, layman's explain it to grandma type term, not totally accurate. The logical volume manager, let's make this my root drive, okay? This is my root boot drive. And you can make these really pretty generic, so you can just roll them out as much as you want. And then what we'll do is, through today's lecture, we will create a logical volume, and we'll make it really simple to go across all the drives. Now, the buzzwords that we need are like this. We have PV, which stands for physical volume, okay? Then we have BG, which is volume group. And then we have LV, which is logical volume. And these layers of software stack on each other, okay? So what you do is you take your drives. Now, here's the thing about logical volume manager is, let's say, okay, I'm going to run a database and I have this problem with this database. My boss wants 10 years of online history and business is picking up. I'm never going to have enough disk. So what do I do? Back up and restore my database every time I need to put in more disk? No. What you do is you simply add another hard drive and you extend the volume group, and then you extend the logical volume on the volume group. Voila, more space, no downtime. That's the sweet spot, is it reduces your downtime dramatically, okay? Imagine turning off a company like I had to for a half an hour a day just to do a backup. That's a lot of pain for a company to endure, okay? All right, we're not going to do 4, we're going to do 3, okay? Now, let's talk about how these fit together. So if you can see my, can you see the blue box above the 3? Or is it too fuzzy? My camera, I can't really tell. Can anybody shout out and say, can you see the blue here? Can you see that? Kind of, sort of?
Yes, I can see it.
Oh, good, thank you. All right, so The black are the actual physical drives you put in hardware. The blue is going to be my volume group. So I'm going to make all three drives as one. Let's say you need a 20 terabyte drive and you don't have enough money to buy a 20 terabyte drive. So you have three 10s and you put them together and it looks like a 30 terabyte drive. The operating system doesn't care. Now, some people say, well, using Logical Volume Manager, you need to use raw disk, it gets speed. That's pretty much been mitigated based on where the development of hardware disk drive technology has come and where it's actually going. They've made this stuff so good that it's you can measure a difference, but oh man, it's such a small difference. You wouldn't even notice it. For the most part, you don't notice it because it's queued up into RAM anyway, okay? All right, so this is the volume group. And then let's say I want to create my two 10 gig or my three 10 gig disks into two 15 disks, two 15 gig, okay? Well, I can do that with the logical volume. I just say I want this much disk and this much disk to be 15 gig here, 15 gig here. My volume group is all the same, which is 10, 20, 30 gig. And then my physical volumes are all 10 gig, okay? Now, this brings some optimization. One, it gives you the ability to make the first 15 gig smaller or larger as needed live while you're running. Same with this one. You can add space to your volume group live while you're running. Now, if you have the really expensive hardware that supports hot plug-in, guess what you can do? You can add a hard drive, use the software, initialize it, extend your volume group, extend your logical volume, all with no downtime. That's pretty trippy. Now, in the VM space, that's not quite true. You can't really mimic this in a virtual machine because when you add a hard drive, the virtual machine is not smart enough to give you hot drive cards, okay? That's just, you know, that's beyond reasonable, okay? But on high-end hardware, this really does make sense. This saved our bacon so many times at Foster's because we bought, I can't remember how many hard drives, but it was all at the same time. And I don't even remember how big they were, but we bought like 90 of them and we populated this big, massive tier 1 storage fiber channel. It was really fun to put together. And what happened is that day one, we had, maybe 2% drive failure, okay, day one. So we get the bad drives, send them to IBM, they send us new ones, put them all in, everything's good. And then right around the second month, we had a bunch of more hard drive failures. And then we pulled all those out and put in all new ones. And then from that point on, they ran really, really well. So note to self, when you buy a lot of hardware all at the same time, plan on having failures at the same time. Like changing all your light bulbs at the house at the same time. They're all going to go out relatively at the same time, okay? Yeah, the bathtub curve, I like that. Isn't SATA hot pluggable? Depends. The drive, maybe, but the controller may not be. Hot pluggable controllers are more expensive, okay? supports hot plug. Oftentimes you get into SCSI, which is different than SATA. SCSI adds some other optimizations at an even lower level. And I happen to like using SCSI on mid-tier servers. If you've got the money, you want to use tier 1 storage, which is running with fiber optic and fiber channel, so you can get the absolute fastest speed from your drives to your CPU, because you're going to have a bottleneck. And it works, and I'll draw this picture on the board just because it's cyclical and it happened. You start off, you have a CPU that's too slow, so you upgrade your CPU. Well, then your disk is too slow. We'll call it IO for the sake of argument. Then you upgrade your whole disk subsystem, and now your RAM is too slow, so now you have to update your RAM, and then you start all over again. Okay, these are going to be the pain points where your optimizations have to happen. CPU, then IO, then RAM, no particular order. It's just, that's how it works. Okay, welcome to the world of computing. Okay, we are on a change is your only constant. Okay, so that in essence is what the logical volume manager brings to the table. It brings it brings simplification of adminning, because backing up makes it easy. You just back it up like you normally do. And depending on your database, you can back up hot. Okay. Some databases, you never back up hot. You just synchronize them. So you have another machine, you have a master slave, and anything that changes on the master goes to the slave. And then you back up the slave. That's a good way to do it, because now you actually have your slave is actually ready to run hot as soon as you need it. Okay, primary, secondary, same idea. Okay, this is why cloud infrastructure is a thing. Okay, and it's not going to go away, folks. You know why? Because people like us get expensive, and if we can outsource and reduce headcount, you can save the company money. But if you're always if you're in the position of helping other people get rid of people, you will always have a job. Rat eat rat, right? Okay. Kind of sad. True. Okay. All right. Now for some nitty gritty. When you initialize a hard drive, you can use either the old school MBR or the new school GPT formatting of the hard drive. Now, write those down. GPT, MDR. What do they mean? How do they work? This is a low-level hardware disk thing that you need to know. For example, I just upgraded 30 machines. They all have basically 4th generation, 1 terabyte, NVMe, non-volatile memory hard drive. And boy, are these machines fast. But all the machines are configured to legacy BIOS. So they naturally default to boot from one of the hard drives before my super fast drive. That's kind of a pain. So I had to jump through some hoops with the operating system and kind of, bludgeon it beat it into submission, as we say. Is that I had to kind of force it to do what I wanted to do through the boot process. Now that could have been completely mitigated if I had the GPT working on all this hardware. And I checked into it. That required a BIOS update. That required a controller update. And I go, nope, not this time. Next big upgrade these machines get is called a replacement. Okay. But this low-level formatting is step 1. You actually have to tell these drives that they are going to be part of your logical volume manager. Then you initialize them. And then you say, what drives you want over or what drives do you want in your volume group? Now, I could also split my volume group in half here, or not so much in half, but say in thirds, and make a 10 gig volume group here and a 20 gig volume group here. Once these are created, it's not hard to move them around, but you just have to have a lot of disk to move it while you're doing the conversion. So in our case today, we are going to simply make one big volume group that goes over 3 drives, and then we're going to split the logical volume into 2 drives, okay? All right, and then we're going to walk through the actual commands to do this, okay? So that's kind of what we'll be doing in the big picture. So let me go back to here, screen 2, sharing. All right, and while that's up, let me bring this up. I put some notes out there. There's just too many. I'm so used to having separate workspaces, like having 15 different workspaces and having windows everywhere. Yeah, I get lost sometimes, but it's nice. Okay, so back to a screen share, and you should be seeing my logical volume or my Debian 11 here. It says 1139. Okay, so I'm going to log in, and I'm curious. Whoops. I want to see if I have. Nope, it's only got the one desktop. Okay, good to know. All right. Okay, so to find out what I actually have, I use the df command, and I say H for human readable to tell me how big they are. Okay, so I have 13 gig available, and I'm using, and we'll say 6 gig. Okay, 30% full. All right, but you notice I only have the one drive, SDA. All right. And what is this number 1? That's the partitions. In your MDR DOS-based partitioning scheme, you only have 4 partitions to play with. GPT, that would be MDR, has 4. You know what? I'll just put it over here. I'm making some notes here for you. MDR format has 4 partitions. And GPT format has 1024 partitions. Okay. All right. Now, what I'm doing with my notes here is I'm running a Jupyter notebook off philipsd.com in a directory called 210, and it's called LVM setup. So this is a live file that you can go look at. You won't be able to change it, but you can look at it. I just discovered I could do this just recently, and I go, this is kind of slick. I can make my notes live available to you as I screw them up. Okay, so this is when we format our disk, and we can use the commands from the command line, either Fdisk for the old stuff, and then you can use gdisk for the newer stuff. They kind of, that's not 100%. You can actually use Fdisk for GPT, and you can also use gdisk for MDR. The difference is, the big difference between these two tools is supports scripting. So when you need to provision 30 machines, it's a little easier to set it up with that. I wonder if spell check. I guess I spelled it right. Okay. All right. Okay, and the question is, what's gparted? It's mostly Fdisk underneath it. Okay, it's just a pretty cover. It's a pretty screen. It kind of handles Fdisk, and the next piece is MKFS file system. That says make file system, and then you can pick what you want here. FAT32. ext4, blah, 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 okay? A bunch of those, okay? All right. So what I need to do is, well, if I'm going to create logical volume manager, I'm going to play with a couple of commands, and I'm going to start with, how many physical volumes do I have? Uh-oh. How many volume groups do I have? Uh-oh. How many logical volumes do I have? Uh-oh. What this is saying is that the operating system does not have the logical volume manager subsystem installed. So what do? Well, I install it. Well, what's it called? I don't know. Let's figure it out. Let's say apt search. And I'm going to say LVM and see what it comes up with. Wow, look at all those things. There they are. This is what it's called. I want you to notice it says 2 on it. Okay. Logical volume 2. Okay. And basically, there's all kinds of things you can do with it. So let me make this screen a little bit bigger. Well, maybe not that big. Then I won't be able to. Okay. So I say sudo apt install LVM2. And what this does, if I can remember the password to the VM, is it installs it. Notice what it's saying. It's installing all these pieces. Okay. All right. And I say yes. Now, when you're installing software and you don't want to say yes a bunch of times, you just put the yes right there. Okay. All right. And so there we go. So I'm going now. Notice what it's doing. When you install LVM, it actually generates a new kernel for you. Okay? It's actually compiling for you the components you need for your kernel. Okay, it's installing a subsystem module. It's actually not part of the kernel. It's a module that gets loaded. And I want to see if I can copy this and paste it into my notes. Oops. I do need to hit the right button though. Yay, it works. That's slick. My copy paste works between VMs because I have my VM set up to do that. Okay, that's up here in VM settings, and you set it for cut and paste. Okay, all right. Now I got still, so here it is. So now I can say PVs. Oh no, it's not there. If I do ls mod, look at all these modules. Okay. So these are modules that create the kernel on boot. Okay, this is kind of how Linux works, is you only need the modules you need. You don't have to load everything all the time. You only load what you need. For example, if you don't have an NVIDIA card, there's no reason to load an NVIDIA driver or a module, so on and so forth, okay? So what I'm going to do, also, I do need to point out that you have to run all of the logical volume stuff as root or sudo or on Alpine Linux and NetBSD or FreeBSD or OpenBSD. There's a command called do as root. Okay. All right. So you have to install it as root. But what I have to do now, before I do anything, is I don't have the hard drive. Darn. I don't have the hard drives to make my logical volume. So why I'm doing this in our virtual arena is this. Let's add some hard drive. This is all there is to it. Edit virtual machines. And let's say add a hard drive. And let's add a hard disk. And take the recommendation, create a new one. And I want to make it, what did I say? 10 gigabyte. Split into multiple files, make as a single disk, allocate all disk now. I recommend you do not use that. Okay. The recommendation for that is because if you do, what it does is it ends up taking over and using up all your disk for something that's in a virtual machine, and you really don't need it for that. Okay. I'm going to open a new document, do a screenshot in here. There we go. See if this works. That's a problem with Windows. It got so many nice features, but man, it's so fat and slow. Okay, let's see if this works. Okay, it's there. Good. All right. So if you say split virtual into multiple files, this means you can copy it to a FAT32 hard drive. FAT32 only supports 2 gigabytes per file size. If you say single file, it'll make one massive file, okay? And then you have to have the right format to copy it to. So I'm going to say single file and say next, but I'm not going to allocate any space to it. So I basically have this generic 10 gig. And what I want to do is give it a name to help me remember what I'm using this thing for. I'm going to say LVM, and I'll just call it D1. Okay, LVM D1. So it's my first disk that I'm installing. It may not end up being my first disk, but that's the label I'm going to give it. And guess what? I'm going to add another one. Hard drive. SCSI. New. Allocate all? No. Use a single disk. Give it 10. And give it a name. LVM D2. Okay. One more. SCSI. New. And we'll make it 10. Single drive. Because what VMware does, and VirtualBox as well, is it creates a chunk of disk for you to run your virtual hard drive, but it will only allocate what it needs until it needs to do something, and then it expands it. That's why when you run your VM, all of a sudden things pause. Okay, you're going, oh, why is it so? Well, it's expanding the hard drive underneath the covers so it won't crash. Okay, see where it says expand capacity? That's a way to make that happen automatically. Okay, and another thing you can do with your hard drives, if you're running out of disk and you don't want to delete things, you can say defrag and compact, and will actually reclaim the unused space in that virtual machine file to give you back disk in your host OS. Okay. So I now have 3 new drives in my Dave 11 box. Okay. So now when I turn it on, let's see what happens. Let's see if I error out, see what kind of happens. All right. And let me show you some of the things that to do probing on your box to find out what's there. Okay. So while that's coming up, let me log in and then I'll make the screen bigger. Okay. It's thinking. This is the default desktop. I don't know what it is. I think it's GNOME or something like that, some derivative. But you right click, you're going, oh man, I don't have the terminal. Where's my hotkey? Control-Alt-T. Oh man. So activities, terminal. And I'll use this one. And there's my terminal. Okay. Make it a little bigger. Actually, the other one had better colors. Let's look at that one, the XFTC one. This one, I believe. Nope. Yeah, that's the one I was using. This one has slightly brighter colors for demoing. Now, all right. Another piece of trivia that you will not find anywhere. At least I haven't found it. Maybe you will. Is this SUDO SU? Okay, let me do this. Let me do this. Okay, what am I doing here? I'm going to say junk equals hi. What did I do? Ancient history. Last week.
You created a variable.
Awesome. Echo $junk. There it is. Now, if I do SUDO SU minus, and then type in my password, it's not there. I do it again without the minus. It's still not there. What's the difference? Well, some of the environment variables, the difference between SU minus, let's say SU, let's say that's a valid user. If I do that command, it's as if I'm logging in with a brand new environment. Everything's been reinitialized. If I do this, it's taking the environment I already have and bringing it to that user. So this is one of those things that can kind of get you into trouble if you do it the wrong way. This is why SUDO is such a big thing now, is everything is SUDO. You got to do this, got to do that. Well, back in the day, you'd run around as root. So basically, this was how I would admin the box, is you have ID 0. Well, you can make a mistake and trash your box in very, very quickly. But that's the way you had to do things, because they didn't have this concept of SUDO. And SUDO and doas also create log files of who did what when So you can say, hey, you broke it. You go fix it. You touched it. Okay. All right. So that's the difference between SU minus and SU without the minus. Okay. And as root, let's see how many users I have. I think I only have one. Yeah. Only have one user. So quick, I add a user. Add user, PKP. Give it the same password so I don't forget. And this is all information. Now, there is other ways to add users. Add user is a script that goes around user add. User add has a lot more fields to fill out, but it's set up for scripting. So you can add 200 users. You wouldn't want to add 200 users this way, okay? So I can now log in as the new user with that minus sign and be that user, okay? Notice my ID is 101, okay? If I do it this way, I will have pieces of root's environment in this environment, which can get things a little messy, okay? All right, so back to LVM. Where are they? Didn't you see me create them? Well, as with anything in tech, there's 10 right answers. Let's start with the hard ones. If we look at the dev directory, oh, look, I see some stuff in there. I see A, B, and C, and D, and G, and oh, well, maybe I do have them. They're just not showing up in the df command, which is right. They're brand new drive, untouched by human hands, okay? All right, so if I do Fdisk minus L, you see all my drives, and one of them, notice that. Ooh, B star is my boot drive. D, A, and C. Look at that, folks. My virtual machine somehow magically renamed my A drive to a B drive. There you're going, oh, what happened here? Well, let's go through the process of setting up our hard drive for the logical volume manager, okay? Now, these are where the commands are, where I'll start showing you the commands. The first thing we want to do is format our drives, okay? So we have, I'll be using the DOS MDR with 4 partitions just because it makes the demo just a little bit simpler. And since we're trying to learn this stuff, let's not make it too complex too quickly. I want catch. That's the FSL. This is this is new. All this stuff is new, okay? This, what they call a UUID. This allows you, it says was on SDA during installation. Well, now it's SDB. Well, I added more drives. My BIOS said, okay, here's my drive. And this information simplifies your life dramatically. And I will explain why. Okay. All right. So let me do an update on this. Let me show you what this is a little script that I run that I just kind of do for my Debian boxes. This can get you into trouble because dist upgrade will upgrade your kernel. Okay, on Debian, this isn't a problem. On Ubuntu, it can be a problem because you do dist upgrade and it installs from 5.13 to 5.15. Now nothing doesn't, now a bunch of stuff doesn't work. It's happened to me, okay? So on my Ubuntu boxes, I do not run this. On Debian, I run it because Debian is what you call trailing edge. They use stuff that's secure. This is not the latest kernel, but it's stable, okay? That's, you know, it's a good reason to use it, okay? So it's not bleeding edge. All right, so I've got my drives and I want to run an update on it. And let's just make sure I got everything updated and everything's happy. So we go through and it updates things and it sees it. And then we'll do this update grub to verify that everything is hunky-dory. Okay, so things are looking good there. So no errors. My system's healthy. Well, let's go to Fdisk and take a look at our drives again. So I have A, D, and C, and these are all empty. So what I want to do is initialize A, D, and C for my Linux partitions, okay? So I do Fdisk, and I'm going to start with SDA, dev, SDA, hit enter. Now, observe the keystrokes carefully. New, N, enter, P, enter, 1. Take the default, blank enter, blank enter. Now I have to change the partition type. Type has to go to, I think it's 80E. There. I have to change it to 8E because I want to make this part of LVM. Oh, look at that. So I can just say LVM. Okay, W. Now, one of the things that you will find in documentation, finally, after all these years, is here documents. Here documents allow you to pipe redirection into a command like Fdisk, so you don't have to key each one in over and over again. And I'll save that for a later date, okay? Here documents, or here docs. It's actually, you'll see it like this, here docs. If you search on this, you'll be able to find it for bash and either here doc or here docs. You'll find this technique extremely useful, okay? And the here docs, you know, it saves a ton of time, okay? So I want to run this again for, what were my drives? A, D, and C, right? So let's go with C. New, partition, 1, enter, type, LVM is the alias, write it. And now I want to do D. Let's say new, partition, 1, enter, type, LVM, great. Now let's do our Fdisk -L. And notice we now all have partitions. Okay. For it has disk label DOS. This is that means it's MDR for partitions. It gives you a unique identifier. It tells you the sector size of the drive. Now your sectors, this changes on the size of your disk on a physical In the world of virtual, it pretty much stays this way. Okay. You can't, but on physical hardware, these numbers move around a bit. Okay. So now, all right, cool. I've got my 3 drives and I'm ready to do stuff with them. So now let's see what happens. All right, it's still not listed because I have not created anything specifically for logical volume. And we discussed that our logical volumes, our LVM manager, we have to start with physical disks. We have to format them correctly. Then we put the volume group on it, and then we format it to the logical volume, okay? All right, so what I'm going to do now is I use this command called pvcreate. And then I give it the device name and the partition. You notice that 1. In the world of MDR, I could have made these partitions 3 and 4 or whatever. I can split each disk in half and make each half of disk part of a different volume group if I wanted to. But just think of the maintenance headache. SDC1, and what was the last one? That's right, SDD1. Now when I do PDs, oh look, it tells me they're formatted, but you notice they are not part of a volume group. They're just empty disks waiting to be used. How big are they? And how much is free? So it's telling me they're totally empty, okay? Well, guess what, folks? The pattern has begun. The next thing we do is VG create, as in volume group, the next level up. And what I'm going to do is give it a specific name, data VG, because it makes it a little easier to display. That was a convention we had. If you created any volume groups, you put VG in there. If you created any logical volumes, you put LV in there. So you know kind of what pieces go where and where they kind of belong, okay? So if I had multiple data VGs, I'd call it data 01, data 02, or ABC, or whatever the convention was. So now I'm creating a volume group. Well, before I do that, let's type in LVs and then create them, and then do LVs and VGs, what I want, VGs, sorry. There is, notice, I now have a 30 gig disk. Awesome. All the room I could ever want. So you find another disk, we have 300 1 terabyte drives. They're old spinners, they're not terribly fast. I could create a monstrous, file share, but the problem is I don't have a box big enough to hold 75 1 terabyte drives, okay? The box, my biggest box will hold 4 drives at once, that's it, okay? I guess I could put multiple machines together, but yeah, then we're getting into a real mess, okay? Don't want to do that. So there's my volume, my logical volume. Now let's do this. Type in VG display. And it's telling you, okay, there's no system ID yet. It's formatted. And areas, read, write, maximum size, the physical extent size. So every time you increase or decrease its size, it goes by 4 megabytes, which means my sector size changed, okay? All right. So we look here, we said, how many do we have allocated on physical extents? This is just how many extents are available, okay? And I got, I'm not using any right now. So I have, 7,600 or so available. And now I have this magic number, the UUID. That's really important. You want that. Okay. Now I can type in VG rename if I need to, because I gave it the wrong name. So I can say, all right, rename it to VG data rather than data VG or whatever you want to do with it. Okay. So there's a bunch of commands. So you can say help, excuse me, man minus K VG and see how many commands are available for VG. Lots of them. You can reduce it. You can increase it. You can extend it. You can convert it, blah, blah, blah. You can do all kinds of things. You can check it, okay? Change something about it, okay? All right. And now that we have our big volume group of 30 gigs, like our picture, we want to do a LV. Let's do a VG scan first. There's only one, data VG, and it's using the metadata type LVM. So there are other metadata types. I'm not going to get into that. Okay. So let's do LV create. And this is how it works for LV create. A little different. You say in for the name. And then I'm going to call it data. And we'll give this one LV 0. Okay. And then I'm going to give it a size. Excuse me, I need the dash size. No, we want 15G, right? I need the double. Yeah, I do need the dash. Okay, you can use a single dash in for name or the double dash in for name. And you will find that almost all the Unix tools, you can use 2 dashes or a single dash. The single dash is a shortcut version of the double dash, okay? And when they first started implementing this, there was a lot of wailing and gnashing of teeth because you had to change how things got parsed, okay? Anyway, so I'm doing LV create. I'm giving it a name of data LVG or LV, logical volume 0. And I'm giving it a size of 15G. I'm going to give it 14, just so I can demo something. And then I'm telling it which volume group to put this logical volume onto. Okay. All right, let's do this again and call it 1. Click. So I now have 3 hard drives, 3 physical volume, 1 volume group, 2 logical volume. Okay. So now I can do LVS, shows me what's there, how big they are. And I can do LV just display. And it shows them to me, what their UUIDs are, so on and so forth. And now our logical volume is now ready to be treated like a disk. So I have my dev data VG data LV1 is a chunk of disk that I can allocate to my operating system now, okay? But in order to do that, I have to format it, okay? So I can do that. So let's format it to ext4. So I will say mkfs.ext4. Now, when you use gparted on SUSE, Red Hat, you know, they're out there. There's all these GUIs to make this kind of thing easier. So it's pretty to look at. But you can almost always find the command line version of it so you can script it, okay? And that's my bias is why do it more than once, okay? Just script it. Okay. And let's see, give it, I'm going to format it, and let's format this one as dev data VG data LV0. I'm going to use 0 for ext4, and I hit enter. Pretty quick. Now the next one, how big is it? It's 14 gig. Let's format this one to FAT32. Oh, what's it called? DOS. I might not have that subsystem installed. There we go. I'm formatting it to NTFS. Okay. As you can see, this is blindingly fast. When the open source community started working on the NTFS file system, it took them years to get it figured out because not everybody at Microsoft plays well with open source. Well, yeah, kind of those days are, I won't say over, but there are still things that it's hard to get certain low-level details out of Microsoft, okay? So I'm formatting my second data volume as NTFS, which means I don't know if I'll be able to read and write it from Windows, but we'll see if we can get there, okay? Blinding speed here. But you notice when it created it, it gave it a UUID that the operating system will use. Okay. I'm going to copy this into my paste buffer because I'm going to use that. While this is grinding away, I'm going to say file open terminal, sudo, su, and then login. Now I'm going to show you how this works. Now this is really kind of hard to see, but UID equals. Okay. Now I'm going to give it a mount point, MNT, and I'll just call it data vol 1. And then I'll give it, well, no, it was 0. I'll give it ext4. And then in this case, we say default. And then we say 0 space 2. The format for FS tab is something that you will need to know. Okay, see if I can minimize this, clean it up a little bit, kind of explain how this works. You can see that it gives you these options. Okay. Notice I'm using a mouse with VI. How do I do that? It's a secret. You'll have to pay me $35 and $15 in Starbucks. No, you just load GPM, which is the mouse driver for the command line. And then you can do this, and then you say set mouse, and then you can use set mouse in VI. There's a lot of YouTubes out there for it too. Okay. I'm just cleaning this up a little bit so you can see it. Okay. You kind of get an understanding of what all these numbers mean, because this is important. Because sometimes you'll be adding a drive and all of a sudden the machine doesn't boot. You know, oh no, what happened? Well, your FS tab is screwed up. So you got to go in there and fix it. Okay. Notice my UUID for the CD-ROM is always mounted. I don't really want it always mounted. So I'm just going to disable it. Okay. But this one I need. That's my swap space. Okay. This is swap space. And then this is just my CD-ROM, and I'll move it to the bottom because I don't really need it. And then this is the one I just created. This is my logical volume 0 that I created with the ext4, and I'm giving it default and then 02. In other words, if it doesn't load and it doesn't connect, don't worry about it. Continue the boot process. This one says, if you have an error, reboot and put me in single user mode. Okay, that's what these things mean. Because when you die, what are you going to do? Okay, so I'm going to save that. Let's go back to my other terminal. Come on. Okay, fine. Be that way. Where's the minimize? I need to fix that. So there it is. Volume 1 is done. So I do my LVs. It shows you, and if I do my LV scan, it shows you what they are. And then if I do my LV display, it shows you what they're formatted to. Okay. So you can see 0 is, oh, I guess it doesn't tell you. All right. There's another command that shows you that. All right. Now what I want to do is give you an idea of where we're going with is I want to take this volume here and I want to put it into that mount point that I put into here. Okay. What did I call it? Devol 1, right? No, 0. Ancient history, FS tab, we just edited the file. Okay. So now I can actually type in mount and type in dev, data VG, data volume 1 to the mount point of devol 01. I typed it wrong. Bet you anything. Oh, I didn't save it. So I minimized it. Where'd it go? I want this one. Oh, the other one. Oh, I know what happened. All right. So it's devol 01. What happened is I changed it. This guy knows it's been changed, but the other one doesn't. Okay. So I can say mount. Yeah. Fat finger game. There it is. Now we have a big test. The big test is what happens when we reboot? Well, before that, let's check this. So it shows me how everything is set up. LS block is showing me my block devices, okay, and how they're created. So I have B5 and all this stuff, because remember, I created a 30 gig volume group, okay? And it shows the 30 gig volume group across the 3 disks that I used, okay? But it's only showing some of the, it kind of allocated it on the fly that 0 is across A and C, and 1 is across C and D. This mapping, when you need to move things, is kind of important, okay? And then if I do block BLKID, these are the magic numbers. This is how I get it to boot. Now, why are those numbers important? Well, my BIOS boot order says boot off drive A first. Well, guess what? I'm not booting off drive A. I'm booting off drive B. How does it know? Etsy FS tab is saying boot from drive B. And this is my UUID. This makes your life a lot easier because now you don't have to touch your BIOS to say boot this drive. You can say, I've got 6 boot drives in my machine. And you just say, I want to boot from this one. And you change the FS tab and it will boot from that drive. Okay. All right. So drum roll, please. Let's see what breaks. It's doing an FSCK on the logical volume. Okay. And let's see what some of those messages were as they flew by. So here's again where I use another command. Okay. And go to terminal. Make it bigger. sudo dmessage. This is a big old long file that shows you everything that happened while your machine booted. Okay. So you can see all the things that it's doing. So if there was an error, you can actually look at that and see what's going on. Okay. So when we load the SCSI drive, they're virtual, but what it's doing is it's seeing it as a really high performance SCSI drive. It's the wide SCSI. So it thinks it's a parallel SCSI drive, so it runs fast. Okay. So now if I do DF, looky there, folks. There is my mount devol 0 that has a bunch of stuff on it. Okay. So that was a pretty high level, quick thing about volume groups and mounting volume groups. Okay. So let me look at my notes real quick to show you what we did. Okay. So we formatted, and what we did. So this Ubuntu and Debian work exactly the same as at the command line level. There's different GUIs. So then what I did is I did Fdisk, dev, stb. Well, in this case, it was A. And then I did that. This way, they'll have a cookbook of doing exactly what I did. Now, your drives may show up differently. I don't need that many, so I only need, so I need A, C, and D. You create A, C, and D. And then we created it as 14. No. Yeah, the logical volume is 14. All right. And then so on. Scan. This is 2 ways to do it. Okay. If there was extra space, I'll delete that one. And then what we did is we created the file system, and we called it devol 0, and then we mounted it. And then we looked at it, see if it all worked. And then in this case, we added it to our mount point. Added UUID to MNT devol 1 or 0. Okay. That's what we did. Kind of, I didn't think it was going to take this long, but I guess it did because I explained a lot as we were going. And I will post this with the notes, so you should be able to see it. If you just go to Philips D, let me see if this works. I need to try it anyway. Let me hit File Save and open another browser. Where are you? Did it die on me? Come on. There it goes. Wow, it's slow today. I'm used to working off SSD drives. All right, just a second here. 210 LV and setup. Oh, it's not seeing it. Why is it not seeing it? Okay. I will have to go fix this. I will go find out why this isn't working. Oh, I know why. Hold on. Slow learner here. One of these days I'll remember these steps. Yeah, okay. I'm sorry. This is, for right now, you need the tilde DKP. I have to run a script to push it over to the root Apache directory. But basically, this is what we did today. Okay. And those are the notes, and then I'll have them posted. And then when we're all done, we'll have this, it'll be available for you. And this will give you a nice little cheat sheet for doing it. Now, I put it in this order so you can actually run a script. So you can set up a machine and do this multiple times and play with it. Okay. On that note, that's all I had. Now, if you have any questions, talk about from there. Okay. A favorite Windows 11 KVM, as in kernel virtual module or keyboard video mouse? All right. Okay. So we now have a modified Debian 11 that's ready to go with our data volume. So I'm going to turn this off. And then you can do the same thing for VirtualBox as you do in VMware, but now I can put some stuff in here and say added 3 10 gig drives. Give it the date. Happy Valentine's Day, everybody. And then LVM2. And we did a setup. So just little brief notes over here with the LVM, so I know what I'm looking at, because I probably won't look at this again until next semester. Okay. I have LVMs laying all over the place. Okay. On that note, folks, I will stop the share and stop the recording, and I will see you all online. Have a good day.